Hello. So today's goal is dividing rational numbers. And in order to divide rational numbers, we have a vocabulary term that you need to become familiar with. And that is going to sound very fancy. It's called the multiplicative inverse. You might have also heard of it as the reciprocal. So to define that, the multiplicative inverse, or the reciprocal, happens when two numbers multiplied together equal 1. So here's an example. 1/3 times 3 over 1 equals 3 over 3, which is 1 whole. So again, the multiplicative inverse means when I multiply these two, I'm going to get the product of 1. Let's take a look at how this is applied to dividing rational numbers. Make sure you have multiplicative inverse and reciprocal in your notes defined as well. We're going to start just practicing with the multiplicative inverse, or the reciprocal. Here's a real simple way of looking at it. Step 1, make sure you have a fraction first, and then step 2, flip it. So here I have a -3/8. That's definitely a fraction. All I need to do then is flip it. So this would become a -8 over 3. This is the multiplicative inverse of 3/8. Next I have a whole number, 4. Fraction first. So we've learned that we just put it over 1. And step 2, flip it. So the multiplicative inverse of 4 is 1/4. Here we have a mixed number, 2 and 1/5. First, we need to make it just a fraction. Here we have a mixed number. We have a whole number and a fraction. We only want it in fraction form, so we're going to use our MAC, meaning we start at the bottom, multiply, add, and copy. So that's going to give us 11/5, because 5 times 2 is 10, plus 1 is 11 over 5. And then to flip that, just put 5 over 11. All right, now let's see how that applies to dividing. The first example we're going to go over is when you are dividing by a fraction. So please make sure in your notes you write divide by a fraction and copy this problem down. Here we have 1/3 divided by 5/9. The first step is turn this into a multiplication problem. We spent a lot of time learning the multiplication rules, and so once we turn it into a multiplication problem, we can just apply those rules, just like we do with addition and subtraction. So step 1, turn to multiplication. Just abbreviate that. So how do I do that? Well, basically we can apply our keep, flip, change if you'd like. So I keep 1/3, I change division to multiplication, and then I change my 5/9 and flip it. So I'm going to flip 5/9 to 9 over 5. Now that I have a multiplication problem, I can use everything we've talked about with multiplying rational numbers. For example, I can see here that I can cross simplify. I can divide both of these by 3. 1 times 3 is 3. 1 times 5 is 5. And I'm all set. You may not cross simplify until you have it written as a multiplication problem. So make sure you always start with that step. Let's take a look at another example. Here I have a fraction and I'm going to divide by a whole number. So I have 5 over 8 divided by 6. Well, if I'm going to turn this into a multiplication problem, I need fractions first. So I'm going to rewrite my 6 so that it shows up as a fraction. Then I'm going to keep, flip, change, or copy, change, change, and I'm going to have 5/8 times 1 over 6. Checking my cross products, I can't simplify, so I'm just going to multiply across. 5 times 1 is 5, and 8 times 6 is 48. And I can't simplify that anymore, so there's my final answer. Here I have a division problem with mixed numbers. So, just like multiplication, you want everything in fraction form first. So, 7 1/2 if I go around, would be 15 over 2. That's negative. And if I change this to 10 times 2 plus 1, that's 21 over 10. Now I'm going to keep the change. So negative 15 over 2 times 10 over 21. And then I can multiply these by 2. I'm sorry, divide these by 2 to simplify. So I get a 1 and a 5. And 15 and 21 both have 3 as a factor, so I'm going to simplify that. That's going to be a 5, and that's going to be a 7. So when I multiply this now, I have 5 times 5 is 25. 1 times 7 is 7. Because I have different signs and I'm multiplying, I'm going to have a negative product. And my last step is to divide. So 25 divided by 7 is going to be 3 and 4 sevenths. A negative 3 and 4 sevenths. Last, I have an application problem for you. In this problem, we have a question: how many cheerleading uniforms can be made if you have 22 3/4 yards of fabric if each uniform requires 7/8 of a yard? So I have this entire amount of fabric, and I want to divide it up into 7/8. Step 1, turn this into an improper fraction. 4 times 22 is 88, plus 3, 89, 90, 91 over 4. You would change this to multiplication times 8 over 7. And then I can divide both of these by 4. I get 1 here and 2 here. 91 times 2 is 182. And 1 times 7 is 7. My last step is to divide 182 by 7. I can get 2 out of there. And I'm left with 42. And I can get 6 7s out of there. So my answer would be 26 uniforms. Okay, we're going to do some practice problems in class.